Okay, practice test continued. Number 13. The graph of the function f of x is equal to the absolute value of x is transformed to the graph of g of x equals f of x plus 2 minus 7. Describe the transformation. Okay, well, we have to describe it in words. You'll see the word describe in your diploma. It's imperative that you use full sentences. So for g of x equals f of x plus 2 minus 7, h equals negative 2, and k equals negative 7. The graph of f of x equals the absolute value of x will be translated two units to the left and 7 units down. Okay, write the equation of the function g of x. The equation of the transformed function will be f of x equals the absolute value of x plus 2 minus 7. Determine the minimum value of g of x. Well, the minimum value of g of x occurs at the vertex of the V-shaped graph. Therefore, it'll be at negative 2, negative 7. Now, the domain of the function f of x is the set of real numbers. The domain of the function g of x is also the set of real numbers. Does this imply that all of the points are invariant? Explain your answer. Well, basically, there are no invariant points. I'll just explain. Invariant points are points that are not reflected by a transformation. Not affected by a transformation. So, in this case, the points on the graph of f of x are related to the corresponding points on the graph g of x by the mapping of xy has the image points of x minus 2, y minus 7. So while the domains are the same, each point is affected by the transformation. So there are no invariant points. Fourteen. The function g of x is a transformation of the function f of x. So f of x is in blue, g of x is in red. Write the equation of the function f of x. Well, the equation of the function of the base function f of x is f of x equals x squared. Write the equation of the function g of x in the form g of x equals a f of x and describe the transformation. Okay, so to do this, we need to determine the pattern in the y-coordinates of the corresponding points. So if we take a look at the corresponding points of f of x to g of x, we can see that a is equal to 1/4. And we can see that, see, this is 1 for my y point, and here is 1/4. Here is 4, and the y image is 1. So the equation of the transformed function is g of x equals 1/4 f of x, which is a vertical stretch about the x-axis by a factor of 1/4. Okay, C. Write the equation of the function g of x in the form g of x equals f of b of x and describe the transformation. Okay, so for g of x, I'll put this, here is A, here is B, here is C. So for g of x equals f of b of x, determine the pattern in the x-coordinates of corresponding points. So if we look at the corresponding x-coordinate points, we can see that b is equal to 2. Okay, so I'll put it here. So the equation of the transformed function is g of x equals f of 1/2 x, which is a horizontal stretch about the y-axis by a factor of 2. D. Algebraically prove that the two equations from parts B and C are equivalent. Well, we have g of x equals 1/4 f of x. G of x equals 1/4 x squared. Okay, because our original function was f of x equals x squared. Then we have g of x equals f of 1/2 x. G of x equals 1/2 x squared. G of x equals 1/4 x squared.